Welcome everyone. In this video, we are going to see about introduction to Amazon Elastic File System. Before we get started, let me introduce about myself. Myself Mahendran, and I am an AWS Certified Solution Architect Associate and also AWS Cloud Quest Cloud Practitioner, and I am on the LinkedIn as well. You can connect me in the below handle. Now let's get started. The agenda for the today's session is what is Amazon Elastic File System and how it works, Amazon EFS benefits, features of Amazon EFS, pricing, and followed by that a demo as well. Now let's see what is Amazon Elastic File System. So Amazon Elastic File System provides a serverless, fully elastic file storage so that we can share file data without provisioning or managing storage capacity and performance. Amazon EFS is built to scale on demand to petabytes without disrupting applications, growing and shrinking automatically as you add and remove the files. And also, Amazon EFS has a simple web service interface. We can easily create and configure file systems quickly and easily. The service manages all the file storage infrastructure for you, meaning that we can avoid the complexity of deploying, patching, and maintaining the complex file system configuration. Now let's see how it works. So basically, we will be creating a file system in a simple AWS user interface, and after that, we will choose lifecycle management file access policy to transition files to infrequent access based upon the days which we choose, like 1, 17, 14, 30, 60, or 90 days using the AWS CLI, API, or EFS management console. If files are not accessed according to the lifecycle policy, they are all moved to EFS standard IA, that is infrequent access, or EFS one zone IA storage class, depending on whether your file system uses standard or one zone storage class. Additionally, we can choose the EFS lifecycle management file access policy to transition the files to EFS standard or EFS one zone if accessed, that is on first access. And also, if the files that are read from or written to the IA storage class or moved to EFS standard or EFS one zone, depending on whether your file system uses standard or one zone storage classes. So this is how an Amazon EFS working. Now let's see the Amazon EFS benefits. We can easily create and configure shared file system simply and quickly for AWS compute services without no provisioning, no deployment, or no patching or no maintenance required. And it also eliminates the capacity planning with fully elastic storage and performance. And also, we only pay for the storage we use, and we can reduce cost by up to 92% by automatically moving the infrequently accessed files. And also, we can securely and reliably access our files with a fully managed file system that is designed for 99.119's durability and up to 99.99% of availability as well. Now, let's see the features of Amazon Elastic File System. The first one is the fully managed. As I said, Amazon EFS is a fully managed service providing NFS shared file system for Linux workloads. Amazon EFS makes it quick and efficient to create and configure file systems. So you need not worry about managing file servers on storage, updating hardware, configuring the software, or performing backups. In the seconds, we can easily create a managed file system using the AWS Management Console or AWS CLI or an AWS SDK. The second one is then highly available and durable. As I mentioned before, it is designed for 11 nines of durability and 4 nines of availability. By default, Amazon EFS redundantly stores every file system object across multiple availability zones for file systems using Amazon EFS standard storage classes. If you select Amazon EFS one zone storage class, your data is redundantly stored within a single AZ. So that is a major difference between the EFS standard storage class and the EFS one zone storage class. And also, Amazon EFS is designed to sustain concurrent device failures by quickly detecting and repairing any lost redundancy. And the third one is the elastic and scalable. So with Amazon EFS, storage capacity is elastic and growing, and we can easily shrink automatically as you add and remove files to dynamically provide the storage capacity to your application as needed. With elastic capacity, provisioning is unnecessary and you are built only for what you use, right? And also, Amazon EFS is designed to be highly scalable both in storage capacity and the throughput performance, growing to petabyte scale with massively parallel across from EC2 instance. And it is designed to provide the throughput IOPS, that is IO operation per second, and low latency necessary for a broad range of workloads. And also by default, Amazon EFS performance is designed to scale as your file system grows and can burst to higher throughput levels for shorter period of time, supporting the unpredictable performance need of file workloads. And the next one is the storage classes and lifecycle management. Amazon EFS offers standard and one zone storage classes for both frequently accessed and infrequently accessed files. Standard and one zone storage classes are performance optimized to deliver consistently low latencies. EFS standard infrequent access and EFS one zone infrequent access storage classes are cost optimized for files which are accessed less frequently. And the next one is the throughput modes. By default, Amazon EFS file systems are built to provide throughput that scales with the amount of storage in your file system, and also it supports bursting to higher level for up to 12 hours a day. And also for throughput intensive workloads, EFS offers two options for delivering higher level of performance dependent of your file system storage. One is an elastic throughput and second one is the provision throughput. Use elastic throughput if you are unsure of your application peaks throughput needs. With elastic throughput, performance automatically scales with your workload activity and you only pay for the throughput you are using it. And use provision throughput as you are already aware about by the name. We can use this kind of throughput when we are expecting the workload to consume a higher share of your application's peak throughput capacity. And the data protection. So in the data protection, there are two. One is Amazon EFS application. It can easily replicate your file system data to another AWS region or within the same region within a few steps. And the second one is an AWS backup. It is a fully managed backup service that centrally manages and automates backup of your Amazon EFS file systems, which will remove the need for costly custom solution and manual processes. And the next one is the containers and serverless file storage. Amazon EFS runs on AWS container and serverless compute services that require shared storage for latency sensitive and IOPS heavy workloads at any scale. In a single step, Amazon EFS provides application running on Amazon ECS, Amazon EKS, AWS Fargate, and AWS Lambda with access to shared file system for stateful workloads. And the next one is the security and compliance. We can easily control the network access to our file system using Amazon VPC security group rules and also application access to your file system using AWS IAM policy and Amazon EFS access points. And other than that, we also other features of EFS are encryptions and data transfer, and also it supports shared file system with NFS v 4.0 and version 4.1 support as well. Now let's see the Amazon EFS pricing. And for Amazon EFS, there is no minimum fee or setup charge. You only pay for the storage you use for read and write access to data stored in infrequent access storage classes, for read and write access using elastic throughput, and for any provision throughput, we will be getting paid for that. Now let's see a demo on Amazon Elastic File System. In this demo, we are going to create an Elastic file system which will span across an entire region, and we will be mounting it to an instance and copy some of the files to that file system, and then we will mount it to a different instance, and from that instance we will be retrieving the files from it. I have already logged into my AWS account and I have created two instances. One for the first instance where we will be mounting the Elastic file system, and the second instance was created to retrieve the files from the Elastic file system. So here you can see two instances. So this will be our first instance where I'm going to mount the Elastic file system. And once it has been mounted and some of the files have been placed, and I will be using the retrieval instance to see whether the files has been placed into the file system or not from the another instance. And also here you can see the both the instances are created in two availability zones, that is two different availability zones. One is in US West 2A and the another availability zone which I've chosen is US West 2C. And also I want to show one more thing is like the security groups configured for both the instance or the same security group I have used. Here you can see which will allow the port 22 and 80. And here I'm going to restrict access to the particular file system by using the security groups. And also we have another option by using access point. So for now, in this demo, I am going to use security group to restrict access to the file system. So as you have seen, that specific instances are already having the file system security group associated to that. So what I'm going to do is I'm going to create a new security group for the Elastic file system, and I'm going to map the source of that instance security group in here. So I'm just giving a security group name as, and also description. I'm just, as we are going to give access to Elastic file system, I'm giving the description as access to Elastic file system. And I have only one VPC, so I am just giving that same VPC itself. And I am going to add a new inbound rule. So in the type, I am just going to give NFS, as we are going to mount the Elastic file system. And the port range will be coming automatically. The port is 2049. And the source will be a custom. Why? Because we are going to map it to the security group. So this is a security group which was attached to both the instances. So by keeping all the values as default, I'm just going to create this particular security group. Once this is being created, we can go ahead and create the Elastic file system. So this will be the landing page for the Elastic file system. And also here you can see the pricing for each storage class and with the provision throughput as well. And here you can see the benefits and features which was discussed before, right? So here also you can see the benefits and features and also the related services as well. So to create a file system, you can click on create file system. Here it will be asking for the kind of a quick setup. So if you want to create a file system within a second, so this option you can use. So which will ask for a name that is also an optional, and it will ask for the VPC and it will ask for the storage class. Is it going to be a standard or is it a one zone? So one zone means it will store the data with respect to a single AC. But if you are choosing standard, it will be stored data will be redundantly across multiple ACs. So I'm not going to choose quick setup. I'm going to give customize so that we can see all the other options as well. So I am giving the name for the file system as lab file system, and I'm going to use the standard one. And here you can see if I choose one zone, it will ask for which zone I need to deploy. So as I'm going to use standard, it will not ask, it will be shown in the next part and then on the networking section. Here it will ask for the automatic backup. So by default, it will be enabled. So if you don't want, you can uncheck so that uh, automatic backup will not be enabled for the Elastic file system. But from the AWS recommendation, if we create a backup, so it will be useful if there is anything goes wrong, we can easily restore it from the backup. So as this is going to be a kind of a testing environment, so I am unchecking the enable automatic backup. And also here you can see the lifecycle management, as this is also one of the feature of Elastic file system. So this will use intelligent tiering to automatically achieve the right price and the performance blend for our application by moving files between standard and standard infrequent access storage classes. So here you can see which option based on our requirement we can easily select, and accordingly the data will be transitioned to the standard infrequent access. So I am just giving as none for now. And also I am unchecking the encryption as well. So if you do encryption, it will ask for the you can use the by default it will use AWS slash Elastic file system, but if you are using any customer managed KMS key, you can use that as well. And here you can see the performance settings, throughput mode. There are two options are available under throughput mode. One is bursting and another is an enhanced one. So for now, I am going to use the bursting itself. Enhanced mode, it is majorly used for a workload which it requires higher throughput. So on those scenarios, you can use enhanced. So if you choose enhanced, there are under that two options will be available. One is a provisioned one, and another is an elastic. If you are expecting an unpredictable input or output, then you can use elastic. And if you are known like you are estimating your workload throughput requirements, then you can choose for provisioned mode. So for now, I'm going to use bursting. And under the additional settings, you can also see the performance mode. Two options are available. One is for general purpose and another is a maximum input or output. So this particular mode is used for highly parallelized workload that can tolerate higher latencies. So on those scenarios, you can use maximum IO. So I am by default, I'm going with general purpose, which is the recommended one. And here you will be restricting the access, right? So here we will be selecting the security group which we have created for Elastic file system. So I'm just removing these default security groups, and I'm going to add a security group which was created to access the Elastic file system. So here you can see 4 availability zones. Depending upon that, you can have it. So for now, I'm just going with 4 availability zone for this particular Elastic file system. And also as per AWS recommendation, per availability zone, one mount target, it need to be created so that you'll have a better redundancy as well. And also, you can only create one mount target per availability zone. And here is a file system policy, which is an optional one. But if you want to prevent root access by default, or if you want to prevent enforce a read-only access by default, so those policies you can also enforce, or otherwise you can add an IAM principal to this particular Elastic file system, so that the required IAM principal person only they can able to access the Elastic file system. Or otherwise, you can also create custom policies as well by clearing here, and you can do you can put your own policies here as well. So if I click here, automatically the particular policies will be coming in place. So if I click all the four things, all the four policies will be coming in here. So I'm just unchecking all of that. So this will show what are all the options we have selected. So I'm just going ahead and creating the Elastic file system. So here you can see our Elastic file system has been created successfully. If I go into my Elastic file system, here you can see the DNS name of our Elastic file system, and also the metered size. So here you can easily see how much size has been used by the Elastic file system. So basically it will take some time to reflect. For example, if I play some files into the Elastic file system, it will take some 10 to 15 minutes to get reflected in here in the metered size. And as is an Elastic file system, we are also having the metrics as well. So by seeing through these metrics, we can able to understand what is happening to our Elastic file system. As it is a fully managed file system, we can monitor the throughput utilization, IOPS, and client how many client connections. So accordingly, you can increase the throughput as well. And here, as I said, the file system policies you can edit. An access point. For now, we haven't we are not going to use access points. And in the network here you can see the mount target state, it is in creating stage. So once it has been completed, we can go into the EC2 instance and we can mount this particular Elastic file system. And this is replication. We can replicate this particular file system to an additional AWS region as well, or the same AWS region. And also, if I want to attach this particular file system, you can click on attach here. So it will show two options, one with mount via DNS and the second one is mount via IP. So if I select mount via IP, we can select based on the availability zone, we can select, and then we can get the command which needs to be run into the instance. For now, in this demo, I am going to use mount via DNS to this command. And also here you can see fs-00c32610ff kind of an unique ID will be getting generated for every file system, which will be saying as a resource ID. So here you can see all the mount target set are available. So now we are good to go with our EC2 instance to mount our file system. So I am going to click this particular instance and I am clicking on connect. As I have the public IP and also the security group has also been allowed, or the port 22, I can able to access from the EC2 instance connect. So here has been successfully established SSH connection. So to mount the Elastic file system to this particular EC2 instance, we need to install the NFS client. So the command is sudo yum install -y nfs-utils. So as this is the latest AMI and I am launching the instance from there. So already this particular NFS utils package has been already installed and it is in latest version as well. Now I am going to create a new directory for this particular file system which I am going to mount it. So I have created a new directory called EFS and I am going to get this particular command using this NFS client, right? So I just copy this command and I am pasting it. So this particular command will mount the our Elastic file system to this EC2 instance. If there is no error appears, so that means our file system has been successfully been mounted to the EFS directory. So to verify the mount, we can give df-h. Here you can see our file system has been successfully mounted in here. And it is also ready to use. Now I'm just going to change the ownership of the EFS folder to the EC2 user. So now I'm just moving into the folder EFS. Now I'm just going to play some of the files like as this has been open to the internet, I'm just going to uh, download a package, WordPress package by using wget command. So this has been successfully downloaded. To see whether it has been downloaded or not, I'm just issuing the command ls space -l. So here you can see the file has been placed into the Elastic file system. So now what we are going to do is we are going to perform the same steps into the another instance by seeing whether this particular file can be able to see into the other instance as well, as this is an Elastic shared file system, right? So I'm going to this particular retrieval instance and I'm clicking on connect. So same steps I'm going to follow in here as well. I am going to install the NFS client, but it will be already installed. So successfully you have logged in. So I am just going to install the same NFS client to verify again. So it has been already, the package has already been installed and it is in a latest version as well. Now I am going to create a same directory called EFS and I am going to issue the command, same command to mount in here as well. So if it doesn't throws any error, then it has been successfully mounted. So I'm just checking whether it is successfully mounted or not. So this has been successfully mounted. Now I'm going to change the ownership to EC2 user of the EFS folder to EC2 user. And I am navigating to the EFS directory. And I'm issuing the ls-l. So here you can see the file which we have downloaded in the specific instance, right? We can see this file in here as well once we mounted the disk in this particular instance. Now we can write, means we can read and write file to this file system using both EC2 instances. All data in this particular file system will be persistent and available to all EC2 instances which is connected to the Elastic file system. And also to check how much space this particular EFS folder is consuming, we can give du space hyphen h. It will show 22 MB, right? As I said, we can check the disk usage in here as well, but it will take some time to reflect in here, like 10 to 15 minutes. So I'm just doing reflect here. So it will take some 10 to 15 minutes to update in the metered size window. So in this demo, we have successfully mounted the NFS file system on a second EC2 instance and also verify that the existing file which we have downloaded is accessible through the shared file system. Thank you.